Numerical integration is finding a value of a definite integral, which is this. So when we use numerical integration, it's when a definite integral such as this cannot be solved by normal integration, therefore numerical integration is used. When do we apply? It's also the same. When definite integral cannot be solved by normal means, numerical integration is used. Now next we going to trapezoidal rule. Trapezoidal rule is basically just this here. It's just a formula, and the h is derived by the b minus the a over the n. The n is which is a given factor. So now I'll show you an example for trapezoidal rule. Okay, this is an example 1 of a trapezoidal rule. This is a definite integral, and the n is 4. As you can see, the h is b minus a over the n, which is 1 minus 0 over 4, which is equals to 0.25. And here is the table. As you can see from the table, we take the minimum is 0, and this one is the 1. And from there, the minimum increase, we take the h, which is 0.25. So from 0, 0.25, then plus 0.25, so on and so forth, which is 0.5 and 0.75 till we get to 1. So that's why the h is there. And the y, the axis, is used by this. So we sub in the x value, therefore we got 1. And for 0.25, we got 0.9922. And for 0.5 we have 0.9354, and for 0.7 we have 0.7603, and for 1 we have 0. We start the solving of the definite integral using the trapezoidal rule, which is h over 2, which is 0.25 over 2 times y0 plus yn, which is y0 is 1, and the yn, which is 0, and we plus the 2 times the y1 to the yn minus 1, which is for this case is y3 plus the y3, and from there, we use this formula, we get 0.797, which is the answer. Okay, the advantage of a trapezoidal rule is that the n can be anything, even or odd number, and but the disadvantage of the trapezoidal rule is that it's not very accurate. So that's why the trapezoidal rule is used for, and that's all for my presentation.